So what we're going to be doing today, guys, is we're going over the pre-lab activity part of the lab. Okay, so today we're going to go over the problem, the design, the hypothesis, getting our data chart ready, things like that. Okay, we're going to be doing all that. And in the case of this lab, which is unusual, we are going to be writing the procedure as well. Okay, so that's kind of what's on tap for today. It'll take us all class to get all of that done. But we need to have that done for tomorrow, because we're going to be going into the lab, following the procedure we write, filling in our data chart so that we can do the analysis and the conclusion, which I'll talk about another day. Okay, so for right now, okay, when you get to Google Classroom, go to Science 10, and you'll see the first thing in the stream is the Properties of Compounds lab. Just click Open. Right, and you will see that there's a couple of files here. There's the Properties of Compounds lab that's a PDF. That's the lab instruction sheet. I'll be working off of that today, okay, giving you the instructions, things like that, but you have access to that as well. You'll probably want that open, okay, while you're filling in your lab report. Okay, there's the video from last week on the expectations for a lab report. You don't need to watch that right now. I taught that to you last week, but when you're putting your lab report together, it might not be a bad idea to review bits and pieces of it. And then down here is the Properties of Compounds lab report. Yours will say your name on it, okay? That's your lab report. You're going to be filling that in and submitting that file to me electronically on February 26th. That's a long way off because you have next week off. Okay, so we're going to do the lab this week, and then you'll have lots of time to work on it and come in and ask questions and all that kind of stuff before it is due. All right, if you leave it till the night before, then you kind of forfeit your ability to ask for any help, but that's up to you. All right, so it's not going to be due for a while, but we're going to get most of it done in class over the next couple of days. Okay, so you shouldn't have too much homework on that. So when you open that one up, okay, it's going to look like this. It's basically all of your labs will set up basically like this. They're a template. You need to fill in the template. The reason I give you the template is so you don't forget to do any parts. You might want to pay attention. Okay, so you don't forget to do any parts. So we're going to go through what to write for the problem, what to write for the manipulated variables. So I would suggest that as we're going along, you make some notes, maybe right in this document if you want. I don't care where you make them, okay, but you should make a few notes. Obviously, you can go back and listen to this recording as well when you're making your lab report to make sure you haven't missed anything, and so you get the hints again in case you miss them. And then we'll talk about how to do the hypothesis. Okay, obviously the data chart here is built for you already, but you're probably going to need to make a paper copy of that to take into the lab, because we're not taking the Chromebooks across the hall and into the lab tomorrow where stuff could get spilled on them. Right, so you'll need to have a paper copy of this chart for tomorrow. Okay, if it's hand drawn, that's fine. You're just going to transfer everything over to this when you're done. Then there'll be analysis, and the analysis is basically just deciding whether each of the unknown compounds is ionic or molecular, and then telling me what it is. Okay, was it baking soda or vinegar or whatever it was? Okay, you come up with its identity. Okay, the list of possible identities is here in the materials. All right, so there's ammonium. One of the unknowns is ammonium nitrate. One of them is paraffin, which is candle wax. Okay, one of them is hydrochloric acid, hydrogen chloride. One is cobalt chloride, and so on. So you'll have to decide from your observations whether sample A is cobalt chloride or whether sample B is nickel nitrate or whatever. Everyone kind of follow on that? All right, so what we're going to do today is just kind of walk through a lot of the reports. So you're going to want to make some notes, and then once I'm done with my spiel, then you'll have the rest of class to work on the pre-lab part: problem, design, hypothesis, okay, and so on. And that'll take you, and the procedure. So that'll take you the rest of class. Questions before I get into that? Now, when this lab report is done, when you have typed everything in and you're ready to submit it, okay, you click the turn in button up here. Okay, that's how you submit it to me. Don't print it. I'm not taking paper. Okay, this is the only way you submit this lab report to me, is turn it in Google Classroom. I will accept it in no other way. I will accept no other file format. Okay, if you email me a PDF from somewhere, I'm not marking that. I'm marking this and only this file, because this file allows me to track everything you do. All right. You hand me some PDF from somewhere else, I don't know whether you copied that off of somebody or what. Okay, so it's this file and no other. You submit me anything else and I'm just going to not mark it. Okay, everybody with me there? I'm kind of particular about that. right? But it's in your best interest to use this one because, well, it's half done already. Okay, everything's already filled in on it, so save yourself some time. Any other questions? Okay. All right, so in the problem, okay, as we discussed last week, your job for the problem is to restate the one that I have written in your own words as a question, right? So the question I have, or the problem I have written there is, given several unknown samples, how can we classify them as ionic, molecular, acids, or bases in order to find their identity, right? So even though I don't have a question mark at the end of that, I should, okay? That's a question. You need to rephrase that, rewrite it in your own words as a question for the problem. Okay, that's what your job will be before you submit it. Now, for the design, we need to identify our manipulated, responding, controlled variables, and explain each one. Right? We went over that last week when we were talking about the effective light on plant growth lab. Right? So this lab will be a little different. Here's how this lab will work. You'll come up into the lab tomorrow, and at the front, there will be a silver cart. On the silver cart will be a bunch of lab apparatus, okay, like a conductivity tester, a spot plate, pH paper, things like that. And on the front table, there will be a bunch of beakers labeled A through K. All right, in each beaker will be a different unknown material. The idea here is that we're going to run the same series of tests on every unknown sample so that we can find out, so we can find out its observable properties, its solubility, its conductivity, and its pH. All right, if you recall from last week, observable properties are things like color, texture, state, okay, things like that. So, you know, maybe I'm looking at A, and A is a white crystalline solid. Right, so that's what I write, white crystalline solid. And I might mention that the crystals are little spheres. Okay, the crystal shape is small spheres, something like that. Okay, so there's my observable properties. It also has no odor, right? So I might smell it, not snort it. Okay, because I've actually had people that are like get right close to it and go, don't do that. You inhale some of that stuff, and it is not going to go well for you. Okay, you're not going to get a buzz either, so don't bother. All right. So if you want to smell one of the samples, then how do you smell an unknown sample? You waft it. So you hold the beaker in your hand, okay, and you waft the smell towards you with your hand. Okay, so that's how, I mean, there's only like 2 that have any discernible odor. One of them is pretty important to get that odor. The rest of them, basically, none of the solids have any smell at all. Okay, so it's really only worth kind of wafting the liquids. Okay. All right, so I would record those as my observable properties. Then I would take some distilled water, okay, in an eyedropper. I'll show you how to do that tomorrow, and test whether that stuff is soluble or not. Okay. And then once I've made that solution, then I'll test whether it conducts electricity. What does this test tell me? The solution conducts electricity. It's not just a metal. It's what kind of compound? What kind have metals in them? Ionic. This test will tell me unequivocally whether that material is ionic or molecular, and that's pretty important. Right? And then lastly, you take the pH paper, you dip it in, and you check what the pH is. That'll tell you whether it's an acid or a base or somewhat neutral. Right? Those are the tests we're going to be running, and we're running the same tests on every unknown compound. So what am I changing every time I run the tests? The material I'm testing, which would make the material I'm testing what variable? The manipulated variable. I just gave you an answer. You might want to write that down. Okay, so our manipulated variable in this experiment is the unknown compound. You need to explain why. The idea that or the premise that we're working on here is that every material has slightly different physical properties. Okay, So, everything is just a little bit different. So every time I run those tests on a new material, my results should be different. Okay? So are the results of my tests responding to me testing a new material? Not all of you caught that big juicy hint I just dropped for you. Are my results responding to the fact that I'm testing something different every time? Okay. Now, controlled variables are things that stay the same all throughout the lab. So every time I test a new material, what things are going to stay the same? Anything that could affect my tests needs to stay the same, including the tests. I would probably want to test all my unknowns the same way. Agreed? Like that might be a controlled variable. Again, you need to explain why. Right? You need to come up with 2 more controlled variables. That is, other things that will remain the same every time I test something new. They can be environmental. All right? We know that there are some things in the environment that could affect the results of our tests. Okay? We talked about how last week solubility could be dependent on some other things. Okay, like temperature and stuff like that. All right, so think about some environmental things that are going to stay the same throughout the lab. Explain what effect they would have if you didn't control them. That's what has to be listed in your controlled variables. This is a controlled variable. I'm controlling it for this reason. This is the effect it would have if I didn't control it. Okay, that's what needs to get listed for each controlled variable. Questions so far?
Can you put two things as like the same category, like my manipulated is also my responded?
No, they can't be the same. All right, for our hypothesis, okay, our hypothesis needs to contain the words if, and then. All right, we talked about that last week. The if part talks about what we think is the reason or the solution to the problem. Okay? The problem we're doing here is how are we going to identify a bunch of different materials using their physical properties? The premise, as I said a few minutes ago, is that all materials have unique physical properties. If that's true, and we test them all, then everything should have its own set of unique results that would allow us to identify them. So the if part should probably talk about physical properties and if they're unique or not. Okay, so the if part should talk about whether everything has unique physical properties or not. The and part of our hypothesis describes the experiment briefly. Okay, in this experiment, the physical properties of some unknown compounds are being tested. Okay, something along those lines. Okay. EXPT is experiment abbreviated. Okay, that's what EXPT means. All right, so it's a brief description of the experiment. The then part of our hypothesis needs to talk about what we're going to be able to do as a result, or what are our expected findings going to be. So if everything has unique physical properties and a bunch of tests are run to discover them, what are those physical properties going to allow me to do? So then the physical properties will allow me to, or not me, because we only use me in a hypothesis, will allow unknown compounds to blah, blah, blah. Okay, so the then part is what are you going to be able to do, or what are your expected findings going to be? Now, obviously on your lab report, the materials are already listed here. So you don't have to do anything with the materials. It's already given to you. Okay, you can just skip over that part. Okay, the procedure is the next part. We now need to come up with a set of steps to follow in order to perform the tests we talked about last week. All right, and that I just listed here in our chart. Okay, we need to have a set of instructions for finding all of the observable properties. We need to have a set of instructions for performing a solubility test, for performing a conductivity test, and a pH test. And what order am I doing those tests in? Okay, your procedure must be detailed. All right, it's probably going to have a lot of steps. Okay, what I don't want to see is this: a paragraph with no numbers saying, get the stuff you need, do the tests, record the results, and you're done. Okay, if that's what you write, you're going to get a big fat goose egg for your procedure. Okay, because that is not a procedure I can follow. Your procedure needs to be written so that someone who has never ever done a lab before could follow it and get the right data. Okay, it has to be that explicit. Okay, so imagine you're writing it for like the dumbest person you know, and that they would be able to follow it. I know that doesn't sound very nice, but okay, you need to write it and you need to explain everything. Okay, just assume this person can't make any decisions for themselves and has no background knowledge in performing a lab whatsoever. All right, so your first thing in your procedure would be enter the lab and put on safety goggles and an apron. Okay, like, I mean, be that simple. If you don't tell them that, they're going to walk in there with no eye protection and spill acid on themselves and die. Okay, and you'll be responsible because you didn't tell them in the procedure that they should protect their eyes and wear an apron. Okay, so make sure that you're very explicit. Where am I going to find the materials? Step 2, acquire the materials from the front of the classroom. Okay, or from the front of the lab, something like that. Okay. So the tests that we have to run, okay, we want to run the observable properties test first. Okay, so the things that we're going to want to observe in the physical properties test are things like color, state of matter, is it solid, liquid, okay, the nature of it, is it crystalline, is it waxy, if it's a liquid, is it clear or cloudy, right? We want to make a note of all those things. Okay, we want to do an odor test by wafting. Describe to this person the wafting process so that they don't snort the unknown materials. Okay, we have to be very explicit. Everybody following me on that? When you're telling someone how to do the experiment, you also need to tell them what things to look for. All right, so when we're saying perform the observable properties test, okay, we don't want to write step 3, do observable properties, because they're not going to know what that means. Okay, so you would say, perform observable properties test, record the following information, okay? And then you can talk about things like record the color, okay? Make a note of the state of matter. Is it a solid, liquid, or gas, and so on. Be specific, okay? Be explicit in, here's what you need to write down. These are the kinds of observations you need to make in this step. Everybody follow there? All right, once we've performed the observable properties test, we have to do that one first because we want to see this material in its kind of natural state. The other thing we want to tell them is how much of it do we need? Okay. All right. So you're going to get one of these tomorrow in the lab. Okay. It's called the depression plate. Not because it's sad, okay, but because it has little pits in it. Okay. There are depressions in it. Okay, a depression is like a hole. Okay, so you're going to be putting your unknown materials in those little depressions. Okay, we'll probably label them with like a permanent marker so that we know that this one is A and this one is unknown B and C and so on. Okay, that way we can have them all in there at the same time. Or we don't have to keep making trips back and forth to the front. Is that something worth noting in your procedure? That you should get all the materials at the same time, put them in a labeled depression plate. Okay, these are all the things I'm going to be looking for when I read your procedure. How specific is it? Okay, otherwise you're going to see somebody who's going to take an ice cream pail to the front, okay, and dump the whole thing in there and go back to their lab station because they didn't write a good procedure. Okay, all right, so we're going to start with that. So how much stuff do I realistically need? Not very much. Okay, in fact, I would specifically state in my procedure that I would want to fill the depression about 1/3 of the way full with the unknown material. I don't need any more than that. In fact, that'll be lots. Okay, so I would say before performing the observable properties test, one of your steps has got to be, okay, get the unknown materials, fill each depression 1/3 of the way full with the unknown material. Okay, then you go back to your station and you record all of the observable properties, color, texture, states, okay, all of that kind of stuff. Okay, and you write in your procedure how they would do that. Now, the tools that you'll be using to get the unknown materials are either an eyedropper if it's a liquid, or one of these. This is a lab scoop. All right, you might have to pick up the beaker and kind of just pick up a little scoopful, okay, and then drop it in there. Try not to contaminate the other samples when you're doing that, okay? Because I have people that like put way too much in there and then they're like trying to hold it still and then they dump it and it gets everywhere. Okay, if that happens, you got to start over again. Okay, you can't contaminate one sample with another, so be careful. All right, once we perform the observable properties test, then we're going to perform the solubility test, which means now we need to see if each one of these things will dissolve in water. All right, so each of you will have a washed bottle, okay, just a squirt bottle that has distilled water in it. Okay, all you'll want to do is just squeeze it hard enough to get a few drops or a very slow stream of water to enter each depression. If you squeeze it really hard, it'll shoot out a high pressure stream of water, which will shoot your unknown right out of the depression, okay, and probably contaminate all the other things, and then you'll have to start over again. All right, so just a small stream of water. How full do I want to make that? Not too full, because when I perform my conductivity test, I've got to be able to put this tester in there and not have it spill out and overflow. All right, so I would say in performing the solubility test, add water until it's 3/4 of the way full. Okay, now when you're doing the solubility test, understand you have a very small amount of water in here. Are you going to get even a small amount of unknown to dissolve, even if it's highly soluble? What do you think? Like if you want to dissolve sugar, do you need a fair amount of water to dissolve sugar? Yeah, okay. You're probably not going to get it all to dissolve, but you can check and see if it's dissolving by just looking carefully. If it's red crystals and the solution turns red, is it dissolving? Yeah, okay. So if it assumes the color of the crystals, it's dissolving. Okay. If the crystals shrink, get smaller, okay, something like that, then it's dissolving. Another thing you're going to want to do while this solubility test is going on is record the temperature. Okay, all the materials will start at room temperature. Okay, so you put the thermometer in the sample, and this is something you'll want to have in your procedure, and then add the water. Okay, any temperature changes that occur will be small and immediate. Okay, so you'll need to watch for them carefully. Right? They'll be obvious. Any ones that happen will be obvious. If you're getting like a temperature change of like 1 degree, it wasn't a temperature change. Okay, but if it jumps 5 or cools 5, you definitely had a temperature change then. Okay, so that's another thing to watch for. Have your thermometer in there, then add the water. Right? You can even use the thermometer very lightly to stir if you want to. Okay, try not to push too hard though. Okay, everybody follow there. If there's a temperature change, is it dissolving? Yes. Okay. These are all signs that the object or that the material is soluble. Color change, temperature change, crystals changing shape, shrinking, okay, something along those lines are all indications that the material is soluble. If it doesn't change or it floats on top, then it's not soluble. Okay? What if it's a liquid? If I add distilled water to another liquid, how can I tell if they're soluble? If they mix, yeah. Okay. If I can distinctly see two layers, then it's not soluble, right? But if it still looks like one visible part, then it was soluble. All right. So those are things to look for. Again, you'll want to mention that in your procedure. In performing the solubility test, the following are signs the material is soluble. Because in your chart, all you're going to record is if it's soluble or not. Okay, so you need to know, was it soluble or not? I mean, you might want to say very soluble or maybe a little bit, okay? But in general, it's kind of a yes or a no. All right, the next step then, after we perform the solubility test, is to perform the conductivity test. So you're going to use these little conductivity testers with the 9-volt battery on the top, okay? In order to check and make sure that they're working, there's a little button on the side here. Just press that, okay? And the on light will come on. Okay, that indicates it's working. All right, then put it in the solution. Okay, if you start it, what it'll show is basically a number of lights. Only one light will light up, but it'll go to whatever the number is for the conductivity. Basically, anything 7 or higher is highly conductive and is likely an ionic compound. Okay, anything lower than 4 is not conductive. You will get a couple that will be like 1 or 0. Okay, those would definitely be what kind of compounds? Molecular compounds, all right? So basically, for your instructions for that, it's push the on button and put the tester in the solution. What should I do with it after that? Rinse it off. Tap water or distilled water? Does tap water have ions in it? Yes, don't use tap water. Okay? If you use tap water, you could get ions on the tester, and then the next time you test something, you'll get a false reading. So always rinse it with distilled water. That's a molecular compound and has no conductivity. Okay? So it won't affect your results. Okay, the last test you're going to perform is the pH test. Okay, so you'll each get a vial like this one, okay, and inside is pH paper. All right, you could, with each little piece of pH paper, you could probably test 2 different solutions. I would pull it off and tear it in half. All right, it's not like we're dealing with large amounts of anything here. So peel it off, tear it in half, okay, place it in the solution. Don't leave it in there very long. Just put it in there so that it's wet, take it out and compare it to the color chart that is on the vial itself, and then record the number in the chart. Okay. That's it. You're doing those tests for every one of our unknown compounds. Okay. Once we have that data, okay, but that is we have this chart filled in, we should be able to figure out what each substance is. All right. So if, for example, I had a white crystalline solid that was fairly soluble in water and conducted electricity really well and had a pH of about like 8, okay, that would probably be sodium chloride. Probably be table salt. All right. If I had a red crystalline solid that conducted electricity, then I'd probably be looking at something containing cobalt, and so on and so on. You guys kind of follow how we would figure out what each thing is? Okay. So it's important then to get good data. Now, in regards to the getting good data part, I will be posting in this activity tomorrow my observations video. All right, so I did this lab and then videoed it, okay, as I was doing it, so you can double check and make sure you got the same readings I did. I would advise you do that, okay, just in case something happened, okay, and it might not even be your fault. Somebody might have contaminated the original sample or something like that. Those kind of things can happen, so it's always good to double check your data against mine. Okay, all right, are there any questions? Okay, so all we're doing today is getting the design problem, design, hypothesis, and procedure written. Okay, those have to be ready for tomorrow so that we can do the lab and fill in this chart. When we come back from the lab tomorrow, I'll talk about the analysis, conclusion, and evaluation. Okay? Now, I would advise that you do this in groups, but if you really want to do the typing part by yourself, that is fine. Tomorrow in the lab, however, you do have to work in groups. Okay? Those groups should be 4. Okay? No more than 4 because there's really only 4 spaces at a lab station to work at. Okay? More than that, and it's just crowded and dangerous. Okay, I'll let you guys choose your groups. If you end up and you don't have a group, I'll put you in a group tomorrow. Okay, but if you want to do this part with a group, that's fine. And I would understand if your procedures were very similar. What should not be similar are your explanations for your variables and your hypothesis. Those should be independently done. All right, you can work on them together, but you've got to word them differently for each person. Okay, it has to, I don't want to see 3 lab reports handed in that are identical. Okay, if I see that, all 3 people will get a 0 because I don't know who did the work. Okay, everybody's lab report should be at least a little bit unique to them. Yes, a lot of stuff is going to be similar because you worked in a group. Your observations will be identical to somebody else's because you work together tomorrow. That's fine. Okay, but the other stuff needs to be independent. Okay, same thing. Okay, all right. Let's use our class time effectively. You still have 45 minutes to get all of that part done. And honestly, guys, that is the most time-consuming part of the lab report. The problem, the design, the hypothesis, and the procedure. Okay, you're getting class time to do that instead of it being for homework. So let's get it done in class today. Remember how thorough I'm expecting that procedure to be. Okay, very, very thorough. Now, one thing to remember. You're performing the same tests on every sample. Do you need to write those tests out 12 times? No, just make the steps and then say repeat steps 2 through 10 or whatever it happens to be for you for each unknown sample. Everybody follow? Otherwise, your lab report is going to be 20 pages long and it's going to be a bunch of it copied and pasted for each thing. We don't need to do that. All right? Okay, let's get to work. If there's questions, just fire away.